Hey y'all, happy day. Happy whatever day it is that you're watching this video. I'm super glad that you took the time, that you're taking the time. Here is a warm up for you. If you will knock a couple of problems out and then pause the video, knock these problems out, and then come on back. Alrighty, these two problems are examples of the triangle sum postulate, which says that all three angles of any triangle sum to 180 degrees. Now for number one, you probably can just sort of guess what to do. Take that 180 degrees, subtract 62, subtract 39, and that's going to give you x. And you'd be right, my friend. That's a great way of going about it. But when we structure it in terms of an equation, it helps us build good habits so that we can solve a question like number 2. Here's what I mean. The triangle sum postulate suggests the equation that we want to use, and that is that all three angles of any triangle sum or add to 180. So in other words, if we take x and we add it to 62 and we add that to 39, we know we're going to get 180 because that's what the postulate says. And so now we can solve this equation. And by the way, you're going to get the same answer as if you took 180 and subtracted 62 and subtracted 39. But writing the equation out builds good habits. So let's combine like terms. 62 plus 39 is 101. So x plus 101 equals 180. And then subtracting 101 from both sides gives us x equals 180 minus 101, which is 79 degrees. Done. Now, number 2 is solved exactly the same way. Even though it looks significantly more complicated, it's still a triangle. And the triangle sum postulate still says all three angles of any triangle sum to 180. And so that's why we want to build good habits when we do problems like number 1. Because now we can just take exactly what we did in number 1 and put in what we see in the problem of number 2. In other words, we know that x plus 3, which is this measurement here, plus x minus 5, which is this measurement here, another angle, plus 2x minus 6, which is the third angle, has got to equal 180 degrees because the triangle sum postulate tells us so. And now we're going to have to solve for x. And so we're going to combine like terms. We've got 1x plus another x for 2 x's, plus 2 more x's for 4 x's. And then 3 minus 5 is negative 2. And then negative 6 is negative 8 equals 180. And then adding 8 to both sides gives us that 4x equals 188. All right, last step, dividing both sides by 4 gives us x equals 188 divided by 4. 188 divided by 4 is 47. Yay. So we know what x is. That's great. And we are being asked to find the measure of the unknown angles of the triangle. Well, we know that x is 47, and 47 minus 5 is 42, so we know that angle's 42. And if x is 47, x plus 3 has got to be 50, right? And then this third angle we could get a couple of ways. We could jam a 47 right in there and go 2 times 47 minus 6, or we could subtract 50 and 42 from 180. It's all the same. 180 minus 50 minus 42 is going to give us 88. 88 degrees, all the way done. So the point of this problem is to tell you that sometimes in the case of number 1, if you know the postulate, you can just do a little subtraction and that's great. In the case of number 2, you're going to have to understand what the postulate is trying to tell you specifically. That all three angles of that triangle are going to sum to 180, and that's going to help you build the equation. And that's the point of postulates and theorems, to help you solve problems. All right, so get that notebook going, start a new page, write some questions on your last set of notes, write a summary on the notes before that. If you have them, you might not at this point. I'm telling you, you'll never regret keeping a good notebook. Go ahead and pause and take the 5 minutes that it takes to update your notebook. Alrighty. Okay. So at the top of your new note page, you're going to write the topic, triangle midsegments, and then you're also going to write the essential question: how are the midsegments of a triangle related to the sides of the triangle? I think I just broke my calculator. Did you hear that? Oh no, it's fine now. I squeezed it too hard. Make sure that topic makes it into the table of contents of your notebook, and let's do this. So we've been talking about triangles for a while now, and we're going to keep talking about them for a while now, so enjoy. One of the reasons why we talk about them so much is that they hold a fair number of interesting properties. Triangles have a lot going on, and much more than you'd expect. And so there's all kinds of stuff that can be revealed by the study of triangles. Also, triangles hold up the world. Bridges, buildings, bicycles, all of them have triangles involved. And so when you understand how triangles work, you can use them to make stuff, which is kind of cool. One of the properties is the relationship between a triangle's sides and its midsegment. So let's discuss what a midsegment is. A midsegment is a segment that connects the midpoints of two sides of a triangle. A segment that connects the midpoints of two sides of a triangle. So when we're looking at a triangle ABC over here, we see that D, this point here, is a midpoint. And how we know is because it cuts AB exactly in half. And then E is also a midpoint. It cuts BC exactly in half, creating two congruent segments. And since that's the case, then we know that this is a midsegment. Any segment that connects the midpoints of two sides of a triangle is called a midsegment. Now, midsegments are interesting because they come with a theorem, and the triangle midsegment theorem says this: the midsegment of a triangle is, now this is the first thing that's true about them, parallel to the third side, and here comes the second thing that's cool about them, is half as long as that side. The midsegment of a triangle is parallel to the third side and is half as long as that side. So there's two things we know about midsegments, two totally predictable relationships between midsegments and that side that is not connected in that midsegment relationship. The first thing we know is that if you have a midsegment, it's going to be parallel to the third side. And that's kind of cool. Just by the nature of being a midsegment, you already know that those lines are going to be parallel. The other thing that we know is that the midsegment, in this case DE, is half as long as the third side, in this case AC. In other words, if you take the measure of DE and you multiply it by 2, you get AC. Let's look at it this way. If AC is 14, then DE is 7, right? Because the midsegment is going to be half that side. If DE is 4, then we could multiply that by 2 and get AC, which is 8. Because the third side is always going to be twice as big as the midsegment. The midsegment is going to be half as long as that side. That's how this works. So let's put it into practice. Here's a triangle, ABC. We've got a point D that is the midpoint of AB. That's what those congruency markings mean. We have E, that is the midpoint of BC. Again, more congruency markings. This is the exact same triangle as we had before, and we are being shown that AC is 14 units. Now we know the midsegment of a triangle is both parallel to the third side and is half as long as that third side. So DE must be 7. Not a whole lot to think about. And that's nice when theorems that sound complicated result in kind of simple ideas. Let's find CD. Well, first of all, we have to know that BE is a mid-segment. So let's make it a mid-segment by saying that those distances are equal and that those distances are equal. And the second we have those midpoints, B and E, connected, then that is a mid-segment. That means that BE is parallel to CD, but that's not really going to help us find the length of CD. We need the second part, which says that the mid-segment is half as long as the third side. In other words, if you take this 3 and multiply it by 2, you're going to get CD, which is 6. Alrighty? That brings us to problems like this. So just a different way of looking at the same theorem. Number 1, we're going to mark up the figure, and then we'll go back and do it again for number 2. These are separate problems, but we're going to use the same figure for them. So let's work our way through this. If GA is equal to HA, and HB is equal to JB, is AB parallel to GJ? What? Let's mark this figure so that we can understand it. If GA, so that segment, is equal to HA, that segment, and HB, this segment, is equal to JB, that segment, is AB, this one here, parallel to GJ, which is this one here. I suggest that when problems are hard to interpret like this one is, drawing out that figure and marking on it can be really helpful, and it doesn't have to be pretty. You're going to be the only one who sees it, but it might help you see how this problem works. All right, so what we know now is that A is the midpoint of GH, because that's what those congruency markings are telling us, and B is the midpoint of HJ, because that's what those congruency markings are telling us. Now, if that's the case, if A and B are both midpoints, that segment that connects them is a midsegment. And from the midsegment theorem, we know that the midsegment of a triangle is parallel to the third side, which means that AB is parallel to GJ, and we can say yes. Definitely parallel. All right, let's take this second problem. Oh, what in the heck? I'm trying to erase. It's drawing instead. That's fun. Okay. All right, so let's take a peek at this one. If AB equals 3x plus 8 and GJ equals 2x plus 24, what is AB? Okay, well, let's start labeling this figure. We're assuming that this relationship is still true. So let's mark it. If GA and HA are equal, and these guys are also equal, furthermore, if AB is equal to 3x plus 8, and GJ is 2x plus 24, this long side here is 2x plus 24, then what is AB? We're trying to find the length of this. Okay. Well, if we're going to find the length of that, we need to have x. And in order to get x, we need an equation. And in order to get an equation, let's see if the theorem will help us. Well, the theorem says that the midsegment of a triangle is parallel to the third side, which isn't very helpful right now. But it goes on to say that it is half as long as this side, the third side. So this 3x plus 8 must be half as long as this 2x plus 24. So if we took this 3x plus 8 and we multiplied it by 2, we'd get 2x plus 24. I mean, we already know that from the problem we just did before, that would, like, if AB was 3, then GJ would be 6, or 2 times 3. If AB was 7, then GJ would be 14, or 2 times 7. If it was, I don't know, 27,000, you'd multiply 27,000 by 2, and you'd get this GJ side. So let's do the same thing with 3x plus 8. If we take 2 times that midsegment, we get the length of that third side. And that's how you set up this equation. Because every midsegment is half the length of the third side. In other words, if you take the midsegment and you multiply it by 2, you will get the length of the third side. All right, let's solve it. 2 times 3x is 6x. 2 times 8 is 16. And that's going to equal 2x plus 24. And we're running. So I'm going to subtract 2x from both sides. And that creates this cancellation here. 6x's minus 2x's is 4x's, plus 16 equals 24. I'm going to need to make this page longer. I gotta put the pen down first. Come on, go. Oh, there we go. Yay. So now we'll subtract 16 from both sides. That creates this cancellation. 4x equals 8. And then multiply both sides by, divide both sides by 4, creating this cancellation, and x equals 2. Fantastic. But we weren't asked if what x equals. We were asked what is AB. Well, that's not a problem, because we know AB is 3x plus whatever x is plus 8. Well, we can take that 2 and jam it in and say 3 times 2 plus 8, or 6 plus 8. So 14, right? 8, 9, 10, 11, 12, 13, 14. Yeah, okay, it's getting late. It's like late on a Friday night when I'm recording this video, and so I'm getting a little bit tired. So this side must be 14. There you go. Now, I'm not saying that's not tricky. It is a bit. You know, I'll give you that for sure. But let's work our way through it. If we know that that side AB, or that midsegment AB, let me start that again. If AB is a midsegment, which it is, we know that it is half the size of that third side. In other words, if you take that midsegment and you multiply it by 2, you're going to get the third side. So it doesn't matter if that midsegment is a number or an algebraic expression. If you multiply it by 2, like we did here, then that's going to equal the measure of that third side, the longer side. And then it's just a matter of working through the algebra until you get the value of x, and then take that value of x, jam it into your equation, and finish the problem. You can do this. Looks a little tricky. We're doing things a little different, but the theorem still tells us what to do. All right, guys, a little bit about triangle midsegments. Your assignment is on Big Ideas Math. The topic, triangle midsegments, and the essential question, how are the midsegments of a triangle related to the sides? Well, now we know, because the midsegment is parallel to the third side, and it is half the length of the third side. All right, you guys, let me know if I can be helpful. Have a wonderful day. Bye.